Hello, we are going to be looking at solving radical equations and inequalities. It is our last section in this unit. Okay, our initial question and information. When you jump, the time that you are in the air is your hang time, and hang time can be calculated in seconds t if you know the height h of the jump in feet. The formula for hang time is t equals 0.5 times the square root of h. So if we had this situation where Michael Jordan had a hang time of about 0.98 second, how would you calculate the height of his jump? And so let's look at how we would solve these type of problems. The basic idea here when you have an equation with a radical and how to solve that is that you need to raise each side of the equation to a power. And so how that would effectively look is if I had, let's see, on one side the square root of x and on the other side I had 3, is, right, I can take the square root of both sides. Okay, and so let me give you an example of how that looks effectively in our situation. So if I have an equation where the square root of y minus 2, and that's what's under the radical, minus 1 equals 5. The first thing I want to do on any of these problems is isolate the radical on one side. This is kind of like when we did absolute value and we isolated the absolute value to solve. In the same way, I'll isolate the radical. So I'll just add 1 to both sides, and that will give me y minus 2 under the square root. So the square root of that equals 6. Okay, next I'm going to raise each side of the equation to a power equal to the index of the radical to eliminate this radical. Now the index of this one is 2 since we're taking a square root. So on the left I'll have y minus 2, and that whole thing gets squared, and that will equal 6 squared. And finally, step 3, I'll solve the resulting polynomial equation. It's important to check your results. Just like with absolute value equations, I can end up with extraneous solutions, so I always need to make sure I don't have extraneous solutions. So with this problem, since squaring and taking the square root are inverses of each other, on the left I'll have y minus 2, and on the right I'll get 36, so I have y equals 38. And I will double check to make sure it's not extraneous by doing the square root of 38 minus 2, and then that's subtracting 1 from that equals 5. So that gives me 6 minus 1 equals 5, and therefore 5 equals 5, so my problem checks. So now let's take this way of solving and put it back with the Michael Jordan question. Okay, so again, I have this equation, t equals 0.5 times the square root of h. His hang time is 0.98, so that's t. So I'm going to plug that in for t, and I'll have 0.98 equals 0.5 times the square root of h. Now step 1 is to isolate the radical. So I'll divide both sides by 0.5, which is basically the same as dividing by 2. And so that's going to give me 1.96. Now the index here is 2 because I'm taking a square root. So step 2 is to, using that index, apply that to both sides. So on the left I get 3.814 equals h. Okay? And then that would be in feet. And I also want to, after solving it, what I want to do is I want to go back in and check it to make sure it's not extraneous. And I can see that if I put 3.814 back in for h, I could actually take the square root of that. It would not be something I'm not allowed to do. And so that does work, and that would be how high Michael Jordan jumped in his hang time, which that's pretty high. I can't think of her name. I think it might be almost as tall as Anna at our school. All right, now if we're going to do this with a radical inequality, if the index of the root is even, we need to identify the values of the variable for which the radicand is non-negative, okay? And so I'll give you an example of this. If I have, there we go, sorry. If I have the square root of 3x minus 6 plus 4 is less than or equal to 7. So again, we're talking about inequalities. So the radicand, if you remember, the radicand is what's inside the radical. So in this case, it's 3x minus 6. I need that to be non-negative since I'm taking an even root. So I would say that 3x minus 6 must be greater than or equal to 0. So 3x has to be greater than or equal to 6. So therefore, in my solution, I have a restraint on my domain, right? X must be greater than or equal to 2. Otherwise, I end up with a negative radicand, and I cannot take an even root of a negative radicand. Now, I just go back and solve the equation algebraically like I did in the first example. So I have my 3x minus 6, and I'm going to go ahead and subtract 4 from both sides to isolate the radical, so that'll be less than or equal to 3. Using my index of 2, I'll square both sides, so that will give me 3x minus 6 is less than or equal to 9. 3x is less than or equal to 15, and x is less than or equal to 5. And so at this point, I would say I have a compound solution where x is greater than or equal to 2 and less than or equal to 5. And so I can test values to make sure my solution checks. 0 would be to the left of 2 on the number line, so I'll try 0. So if I put in 0, I would get, as my input, if x equals 0, I would get the square root of negative 6 plus 4 is less than or equal to 7. Well, that's not going to work, so I can see that that's correct. That to the left of 2 doesn't work. I can try 3, which is in the middle, and I would get, if I did x equals 3, I'd get the square root of 3 times 3 minus 6, and that's plus 4, less than or equal to 7. So that's going to give me 9 minus 6, so that is the square root of 3 plus 4, less than or equal to 7. That's a true statement. And then finally I could try 6, and that would give me the square root of 18 minus 6 plus 4, less than or equal to 7. That's the square root of 12 plus 4, less than or equal to 7. And if you did the square root of 12 on your calculator, you would see that that is going to be greater than 3. And we should know that because this is between 9 and 16, which tells you the square root of 12 should be between 3 and 4. And so it would not be less than or equal to 7. So my solution works. All right, the next video will give you a couple of practice problems.